The driver in articulated lorry. I could be a poet, I wouldn't need to worry. I could be a teacher in a classroom full of scholars. I could be the sergeant in a squadron full of wallers. What a waste. What a waste. What a waste. What a waste. Because I chose to play the fool in a six-piece band. First nine nerves, every one night stand. I should be glad to be so inclined. What a waste, what a waste. What a
was the fabulous Ian Jury and the Blockheads. What a waste, eh? What a waste.
Amazing. I remember Ian Dury. You first introduced me to Ian Dury way back when we were at university together. And I've enjoyed him ever since.
Well, he's just, he's iconic, Steve. And of course, his band, the Blockheads, probably one of the best punk rock bands ever to come out of the UK. And of course, the name Blockheads is a resonance for us, isn't it?
Yeah, it does. Indeed. We're here at our little pre-launch party of Teckel.
And we are the Stanford Blockheads.
That's right. Yeah. You're Blockhead number 1 officially. I'm Blockhead number 2.
We're the Stanford Blockheads because of a few things. One, we met at Stanford.
That's right.
Back in the late 80s. We love Stanford. We love Ian Jury and the Blockheads.
Yeah.
And we love the blockchain.
Yeah.
And that's what we're here to talk about mostly.
And we love this little guy right here.
Oh, it's Chicken Pie. He's the massive inspiration to pretty much everything. So you want to talk about Stanford a little bit, Steve, and go back.
Yeah.
Go back to the old Stanford days. Tell us a little bit about how we met and how that ended.
Well, interestingly enough, gosh, when was that? That's the summer of 1988. And I just signed up to do a summer research project, and I had to get interviewed to see if I was going to be accepted to the team, the research project team. So I walked into the aerospace department at Stanford and sat down in front of Yusuf. He was interviewing me for the position, for the research position, and it was a great project, actually. Yusuf was lucky enough to hire me. Actually, I was lucky enough that he hired me. But we had a great time, and we did a summer research project on designing a reusable reentry satellite for NASA Ames Research Center.
I've got it here. Not the satellite, but there we go.
Yeah, look at that. That was quite a project. We pulled many an all-nighter to get that thing done.
And just looking back, we're 71 pages, Steve.
Wow.
On we were designing a spacecraft. We were ahead of our time.
I think so.
We were designing a spacecraft that could be returned and reused for commercial purpose. And I remember we had to find a safe place to land it, and we went for the Great Salt Lake in Utah, the Great Salt Lake in Utah. And tell me again what your role was on that project, because I find it fascinating to think back to what your role was and what you concluded would be the best technology back then to satisfy that requirement.
Sure. So when I was studying aerospace engineering, my main interest was in the area of thermosciences. So that's heat transfer and gas dynamics and fluid mechanics and rocket propulsion, aircraft propulsion. And so my responsibility on this project was the design of the heat shield of the spacecraft, because that was going to be important. That one of the most important key drivers of this project was economics. NASA wanted to know if they could economically make this happen. In other words, put up a satellite into orbit, launch different experiments, bring it back economically, and reuse it time and time again. So we had to find materials that were economic. And so I came up with this idea of using oak, the wood, as the heat shield. And as we did our analysis, we realized that, of course, oak is pretty inexpensive compared to, say, ceramic tiles or carbon fiber. So, but it turned out to be the most protective material as far as what they call ablation is concerned. And ablation is where the material is burning away from the aircraft, and that's the way it protects the aircraft, or spacecraft in this case. But it's going through air, and so it's generating all that heat, all that friction, and so the oak is burning away. So we used Chinese oak as our protective heat shield for the spacecraft. So that was it. That was my little niche in the project.
And just reminding ourselves here, when we re-enter, we're doing about Mach 22.
Is that all?
That's all. So one has to be concerned about heat, friction, even with a few air molecules around. You're going, I'm just checking our calculations here, 8 kilometers per second.
Not too bad.
Hitting that rarefied air is still significant, the frictional effect. So it was impressive that you came up with Chinese oak as the heat shield material. And I wanted to tell you something. I don't know if you saw this a few years back. A spacecraft, I think from China or Japan, they made the re-entry heat shield out of oak.
Oh, so that's right. You pointed that out.
So you were 30 years ahead of your time in designing that heat shield. So one of the things I thought we'd do, almost for posterity, Steve, because that's going back to early, late 1990 or so. I've got the report. In fact, October the 1st, 1988 was when we signed off on this, and NASA signed off on this and approved the conclusions. So what's that? That's going back 10 years. 30 years.
Can't even count
33 years, Steve. So we got this document from 33 years ago, and what we're going to do with it. Tell everyone what we're going to do with this document today.
Yeah, the great thing is we're going to actually turn it into an NFT, a non-fungible token on the Ethereum blockchain.
Is that what NFT stands for?
Yes.
I always thought NFT. NFT stood for no talent.
Well, it could stand for that too. In our case, that may well be what we prove out.
I see. So I thought. I see. Okay. So what's this NFT you're going to be talking about?
So what we're going to do is we're going to we're here to celebrate the launch of teckel, our blockchain app, our Ethereum blockchain app, and we're going to officially create our first collectible on using the teckel app and with this document. So this document's never been officially, I don't know what you want to say, put in a museum or turned into a collectible or anything like that. So we're going to sign them. This is going to be a signed copy that we're then going to scan or photograph or, get into an electronic format. And then we're going to mint it. That's called minting. We're going to create a non-fungible token on the Ethereum blockchain using our newly developed app called teckel. It's a great application. It runs on the Android OS on all Android devices and free to download soon on teckel.io website. And that's it. So That's
fast forward a bit. We're going to explain what teckel is and why we did it, why we built it. Thanks for that introduction on the first. This is going to be the first teckel NFT that will be available. In fact, why don't we just sign it now and get this out of the way, Steve? So we can. I've got a pen prepared.
Oh man, I'm feeling presidential here.
Right, let's see if we can just. Yeah, let's see if we can. Let's see. I'll just sign against my name.
Yeah. Hey, that's a fancy signature.
There you go, Steve. If you sign against your name.
I don't think that's like rock star signature, man. There we go.
Look at that. So,
all right.
The Stanford Star Lab mission operations for a commercial reusable re-entry satellite. You and I were the first two authors on this, Steve, and we've now signed it. And so this document from 1988 is going to become a no talent artifact on the Ethereum blockchain sometime later today. And you will see it through the teckel app.
Yeah.
So let's just talk a bit generally about what teckel is, why we did it, why we're here. And then I think what we should do is maybe go into a lot of detail about it, because if I think we started teckel, 3 years ago? And it's been almost a full-time effort to get to this point.
Yeah.
So a good question would be, and I ask myself, I'll be honest with you, why on earth did we do this?
I'm still scratching my head.
Well, let's see if we can scratch a bit further and undertake the mission of trying to understand just why we did this and what we expect other people will find useful about it and what the future will hold for teckel and the Web3, what we call the Web3 community at large.
Yeah.
So do you want to talk about why we built this, Steve?
Well, I think, I think there are a lot of reasons actually, but the first big, prodding, if you will, was our experience at Burning Man in 2018. Yusuf and I went to Burning Man, actually in support of my sister and her husband. They had built a big, giant sculpture for Burning Man, and we were part of their camp and supporting them. But we had a big sort of, I don't know, what do you want to call it, hiccup in the beginning of our journey, in that Yusuf had purchased a ticket on, was it StubHub or what? I forgot. So one of the resellers.
Yeah, StubHub. It was StubHub.
Yeah, and after weeks of planning, getting to this event, we get to the gate after hours of queuing up in lines and so on, and they won't let us in because they're telling us that Yusuf's ticket has been stolen. So, that was a real pain in the ASS, as they say. And we went around and around for hours with the organizers there. After many hours, they finally let us in. We actually ended up having to purchase another ticket, right? But we got that later refunded.
It was a very strange. They wouldn't want to admit that there was a loophole for getting in as support staff for a camp, but you had to buy another ticket to make it somehow legitimate that then could be reclaimed. Yeah. But the whole thing was ridiculous.
Yeah.
In that day and age, 2018, not too long ago, 5 years or so, the ticketing was ancient. They were using paper. They were using unique identifiers printed in cardboard. And these things were getting stolen in the mail. My ticket had been hijacked or stolen in the mail system from the original delivery when they were delivering it to the original purchaser. And it got blacklisted at that point in time, but no one knew. And StubHub didn't know, to be fair to them.
Sure.
We didn't know. We bought it in good faith. And it turned out that when we got to the gate, they weren't going to let us in. So I remember there was a very unpleasant 6 or 7 hours in the desert, covered in dust, watching everyone else going in and being stuck on the outside, thinking, going to have to go get out of here.
Yeah.
We got in eventually. But I remember then that we talked a lot at Burning Man about lots of things. But one of the big things that crossed our mind really was to change the way events like that do their ticketing. And we knew back then that blockchain would be the key to this because you have an immutable general ledger, globally available, publicly available, open, where all of these things can be recorded definitively. And the ownership can be traced definitively, as can the transactions and the payments and everything else. So I think that was really the moment that we decided, let's build something using the blockchain and using that Burning Man physical ticketing experience, negative experience, as the catalyst for change. And so, well, teckel didn't really start off as a ticketing solution. We'll talk a bit more about that. But one of the central uses of it is ticketing. And then what I find quite interesting is how in the last year or two, in the last few months actually, event ticketing, particularly musical event ticketing, has become, a big news item internationally because of the scandalous nature of the ticketing industry. The artists want the fans to be treated fairly. The fans want to be treated fairly. There are lots of players in that market who I think, let's be polite, are maybe less concerned about fairness and more concerned about profit. Well, you get, not just in music, but in sports events, football here in the UK, football is a big thing, the biggest sport. And the touts and the scalpers, the people who buy in bulk and resell at the gate for twice, 3 times, 4 times, 10 times face value for profit. It's just another example of how scandalous the industry has become. And the weakest link in this whole chain of transactions is the end user, customer. And they invariably lose out because they love their musicians, they love their football teams, they will pay through the nose to get in through that turnstile. And those who are maybe less enamored by the actual event, but much more enamored by the easy profit, just sit there and take it. Now, there's a whole debate about the morality of that. That's not what we're about. But we are about trying to make that process fair and controllable for everyone. And we believe that in teckel, we have the ticketing side of teckel. That's solved. We've solved every single issue with ticketing. And so we'd like to imagine that we can convince everyone that there is a solution. If there's a will, there is now a way to solve this. It does mean adoption of blockchain. It does mean adoption of Ethereum, which is the currency that greases the skids of the blockchain, the one that we've chosen. But that's coming too. People are waking up to the reality of Web3 and, well, the sort of negative connotations of cryptocurrency are known, but it doesn't need to be negative. I think that's the other point that we'd like to bring, that the whole idea of having a centralized, immutable ledger with a medium of transaction, which is a cryptocurrency, is actually a very positive thing for the fabric of society, for the fabric of commerce. And, well, it's not really us saying it. I think it's pretty much guaranteed that this is coming. And so let's give some really good uses of it, make really good use of this. And the ticketing, I think, is probably the lowest hanging fruit, one of the most obvious transactional issues that we as a community have real trouble with. And I'm looking forward to when we launch this today and when we start explaining it to people, how it actually does solve the issues. I know that on the website and things, we've been trying to reach out to all the interested parties in this, including the governments and the people complaining about it, those who want to regulate it, those who want to improve it, including the big ticketing agencies themselves. We even talked to them. And up till that point, it was all vaporware. Well, of course, you guys would say that. Anyone can say anything. And you talk a good talk. It does sound quite convincing. The great thing now is that we have it built and it's going to be launched onto the world market today or tomorrow.
Yeah.
And then let's see where it goes. And let's spend the next few months, Steve, really trying to get the message across as to the positive utility of this. And hopefully people will benefit from it and go off and launch their own ticket events using teckel.
Yeah.
Or the blockchain more generally.
Yeah.
That's the message. That's the message.
It's coming. It's just a matter of time, is my personal opinion. And actually, it's funny. I remember when I first got introduced to blockchain, it was probably right about when Bitcoin launched in around 2009, 2010. I caught it through the newswire, and I thought, oh gosh, somebody just sent some sort of electronic cash from the U.S. to Japan or something like this. I remember making a mental note, thinking, I gotta check that out. Well, back then I was so busy making chocolate. I was in the chocolate business back then, but so I didn't.
As one does.
I didn't have time, and sure enough, after a while, I just forgot about looking it up. But I had a good friend turn me back on to blockchain back in around 2017, and that's when I learned about Ethereum. And I was actually blown away when I really learned what Ethereum was all about. This concept of smart contracts. Like, what the heck is a smart contract? And my friend had explained to me that it was like, any type of contract. Like, you think of a big legal contract or a real estate contract or something like this, but it's all electronic, and it's sitting on this thing called the blockchain. And it's predetermined on how it is executed by the code itself, and the code can't be tampered because it's decentralized, and it's governed by this sort of consensus mechanism that Yusuf, you like to jokingly call enlightened self-interest, where basically everybody is sort of would you call it game theory? What is that that's actually behind it? I guess it's game theory behind this idea that everybody's going to sort of follow the rules because breaking the rules is too painful. So by following the rules, it's the less painful, more incentivized option. And so you get a whole bunch of people in the group, and they all choose to follow the rules. Because that's the best economic outcome, et cetera, et cetera. So anyway, this whole idea of the Ethereum blockchain kind of really blew me away, and I was like, wow, you could then basically create what they now term this trustless environment, right, where you've got something that can, once it's designed and deployed out, these contracts, these electronic contracts that are governed by software, once it's deployed out onto the blockchain, then it's immutable. And so when we had this issue at Burning Man, we're like, this is the solution, right? This is obviously going to not only solve this problem, but it could solve the problem of voting, for example. You get around the world, you got people saying that the voting systems are rigged and corrupt and so on and so forth. So there's so many real world use cases for the blockchain, and it's just a matter of people, and that's one of the reasons we're here having this little talk. It's just a matter of educating people on what it is, how it's useful, how it brings more justice, more efficiency to the process of agreements, commerce, contracts, etc. And so, like Yusuf was mentioning, that the whole ticketing, for us, when we first got started on this, we weren't thinking about ticketing initially. We had, we thought we created this concept called IQ, and actually our contracts now all are named after the original IQYU contract on the blockchain. and this was more of a communication application, right? We were doing like local communications and stuff like that. But then we had this idea of, well, what about, because the thing about non-fungible tokens, most people have heard about these in the realm of digital art, right? And now you've got a big marketplace out there where people are trading digital art on non-fungible tokens on the Ethereum blockchain, and it's a big marketplace, and there's a lot of trading volume, etc. And as we got into this, we thought, well, what about the use case of just what we now term the empty NFT? This is a non-fungible token on the Ethereum blockchain that doesn't have any content. So all it is it's an integer, basically. You create this smart contract, that's basically just computer software, but it's a mutable contract that you design that's now deployed on the Ethereum blockchain. But the only thing it offers up is actually an integer. Well, we thought, well, that's kind of simple, and you don't have to worry about the content and what people call rug pulls, which we won't get into right at this moment. But there are all these use cases. It could be, like I said, it could be voting, it could be ticketing, it could be actually. I love this use case that we're thinking of the other day of calendar events, right? Say you want to rent a room out, like most people use Airbnb these days to rent a room out in their house, right? But you can use just basic ticketing, which we've obviously got on the teckel platform, to rent out your room. You basically sell a ticket for a day or a week or whatever on the teckel app, and that's your room rental. Or say you're, quote, renting an hour of your time as a consultant. You can use blockchain ticketing on the Ethereum blockchain to do all that.
Yeah, I like to refer to it as the tokenization of space and time, Steve.
Yeah.
And you're right. Basically, selling counting numbers. That's really what it's about. Selling counting numbers, the most primitive form of arithmetic ever invented, comes back to being one of the most powerful and useful. I agree with you. And in terms of, you mentioned game theory, I would say if you wanted to take a game theoretic approach to this, it's really about being able to transact securely and reliably amongst people who don't trust one another.
Yeah.
Without a middle agent, without a bank, without an escrow holder, without anyone to form that kind of unit of trust amongst these two people who don't trust each other. The blockchain fills that role. Cold and efficiently.
Yeah.
And it's the optimization of it that I love. The fact that it optimizes the marketplace completely, not least by cutting out a lot of the fat and a lot of the friction. I like to think of as friction that just erodes the value. So I think that's where maybe game theory comes in. And then in terms of I think you were alluding to the proof of stake validation mechanism of Ethereum. I'd say it's more than just, it's really, the stakes are enormous for those who break the rules.
Mm-hmm.
They're basically bankrupting enormous because the entire stake is up for grabs if you break the rules. And that keeps people in line, basically.
And that's a big stake. It's 32 Ethereum right now. So that's
on one validator node, it's 32 Ethereum, and each Ethereum is what we need to get this.
It's like $100,000. So like 3,000 times 30, basically, or $3,000 times 30.
Yeah, and that's
$100,000 or something. It's in that realm.
It's a huge amount that's at stake if you. It's a huge amount at stake if you try to defraud the network and people on it. So it's really a remarkable technology, the Ethereum virtual machine. It's this distributed, completely decentralized, distributed computing platform with what I like to describe as a layer of ownership. And that's what brings the contractual aspect to the smart contracts. Without that, it's really just a set of smart routines or subroutines, methods in programming parlance, algorithms broken into little modules called methods or functions or subroutines. And that's great that you can decentralize that. But what's particularly interesting about Ethereum blockchain decentralization is you have all that computational capability with this ownership layer sitting on top that's fundamental to the operation of the whole thing. So, and a good example of it is you can define as a programmer, you can define who, in terms of ownership and provenance, who can do what in a given function. And that's the key to having the trust, because the contract has within itself a set of rules that no one on the outside can change. And those rules are transparent. You can read them by reading the contract. Oh, I see. Only this entity owner can do this. But when this happens, that goes there. So if this happens, that goes there as normal programming, but only the owner being able to trigger that, that's not normal programming. That's new. That's Ethereum blockchain or Bitcoin. Bitcoin is really the parent of all of this. In the original Satoshi white paper, one of the most interesting, remarkable things I've ever read actually was that paper from he, him, her, them, whoever Satoshi is. Yeah. It's a remarkable achievement. It reminds me of Claude Shannon's paper on information theory that basically invented modern communication. That paper is breathtaking in what it says. And I think we go back to that all the time, the entropy of information. Every byte counts, and we'll be talking about that at some point.
That's right, every byte counts.
And talking about that, who's this? Who's this we got?
Well, here's our brand ambassador right here. His name's Chicken Pie.
Oh, look at that.
And he's King Teckel.
Yeah, he's King Teckel.
Here, come here, buddy. Come here. Smile for the camera.
Yeah. Oh my goodness. We're going to be this. Oh my goodness. Have a little dry. So
anyway, but before we get off topic there, I just want to say something. That is the brilliance of this whole thing, is the fact that it's all governed by this encrypted ownership mechanism, where basically all the code, the conditions of the code that's running, the conditions of these smart contracts that are running on the Ethereum blockchain, they're all determined by permissions of the owner. So it has this owner given permission, and the owner is determined by what's called a private key and public key pair. So obviously, like you said, Bitcoin was the first to kind of solve this problem, but Ethereum, of course, was the next giant blockchain to come around and take it to the next level with these smart contracts. And so it's about applying this encrypted private public key pair, implementing that sort of technology into the code. And so, like Yusuf was saying, each instruction in the code is determined by these the permissions granted to those instructions by the actual private keys in throughout that whole code.
You're so into the blockchain, Steve, that you trust no one, that you refer to me in the third person, even in this room. That's because you've been completely absorbed into the blockchain. You could actually be a smart contract. You might actually not be real anymore. So I wanted to say something more about these no talent NFT things. Everyone I talk to or have talked to in the past year or two, every time I mention, we're doing NFTs and we're doing empty NFTs, which are NFTs with nothing in it, people quite reasonably raise their eyebrows and say, this is all a load of rubbish.
Yeah.
And I say, well, you're thinking about these massively overpriced pieces of digital artwork that so in some cases aren't very good. Not that I'm any kind of serious art critic or anything, but and then they can be rug pulled, it can all be taken away, and there's nothing behind the URL that you're buying. What a load of rubbish. Or as Ian Jury would say, what a waste.
Yeah,
what a waste of everything.
But I want to interrupt you just for a second there, Yusuf. What is a rug pull? Just real fast before just
okay, a rug pull is one of the biggest problems or bugbears of NFTs or no peak talent entities on the blockchain.
Yeah.
Ultimately, the blockchain is just a record. So it's an integer, a number, and you can have associated with that number a URL, a resource locator on the internet, a website, or a pointer to a JPEG image or a video or whatever it is that you're saying this NFT, this non-fungible token represents.
So that content could be like a YouTube video,
Yeah.
or it could be some file sitting on some disk drive in the cloud or something,
could.
Right?
And it is. Invariably it is on the blockchain. The problem is that, I bought this NFT. I've got the integer identifier for it under the contract banner. That's fine. But then I go to get it, to watch it or to play it, and it's gone.
And so just to clarify...
There's nothing behind the URL. It's just been, a 403 error. There's nothing here.
So just to clarify that, so you bought the NFT. So basically your private key instructed on the Ethereum blockchain to send some, Ether. That's the currency of the Ethereum blockchain. It's called Ether or ETH. So your private key instructed to send some Ether to some other key, and then because of that, there was an exchange, and so you, in exchange for that Ether, got this non-fungible token, which exists on the Ethereum blockchain. So that token was moved from the other person's private public key pair over to your private public key pair, right? But then in that, if you looked up on the Ethereum blockchain at that non-fungible token, you have that integer ID associated with that non-fungible token, which is, say ID number 29 or something. But within that would be also embedded in the blockchain itself, say some URI or URL, for example. So it could be a YouTube. So it's like YouTube /.com/ blah, blah, blah. And so you then click on that YouTube link and you go out to YouTube to look at it, and the YouTube is now not available on YouTube. It's been blocked, or YouTube took it down, or so you bought this NFT, but then all of a sudden the content doesn't even exist anymore, right? Is that what you're talking about?
Yeah, and it can be inadvertent. It doesn't need to be malicious.
Sure.
But it can also be fraudulent, that someone scammed someone. They basically, a bit like my Burning Man ticket, there's a fraud gone on. And in the case of the rug pull, the classic rug pull in NFT land, the URL points to nothing. It's dead. It's gone. So when I first heard about NFTs, I thought, well, it's ridiculous anyway, because anyone can copy a file. Once you've got a URL, well, not all files can be copied. I mean, YouTube do a reasonable job of making sure that you've got protection against that.
But you can still screenshot it.
You can
screencast and you record the whole thing.
You can record it. So, and everyone knows that. And this is, the pirating. Blockchain doesn't solve pirating. There's a lot of human behavior that blockchain it can't address. It's a category error in philosophy to assume it can. It can't address a lot of the issues that are endemic in human nature.
Yeah. There'll always be bad actors.
Yeah,
right?
but it can solve a lot. But go back to these NFTs, and I agreed. I used to think, what a load of rubbish, because I'm just buying a URL, and a URL can change, and it means nothing. And I would actually laugh and almost mock at people spending thousands or millions of dollars for NFTs on the blockchain. I'd just laugh at these news items and think, what a bunch of jokers, what a bunch of losers. Until I learned more about it. And when we put TIQYU together, one of the first things we did was we had a bifurcation, didn't we? We had traditional NFTs.
Yep.
And we had what we call empty NFTs. I don't know if anyone else calls them empty NFTs. I don't know if anyone else realizes the utility. But the empty NFT is the ultimate abstraction. How can you rug pull something that doesn't exist?
Yeah, exactly.
But how can there be value in something that doesn't exist? Well, it turns out there can be if you abstract the mapping from the integer to what in the industry is known as real world, or RWA, real world assets. And one can, with a bit of thought, quite easily bind a real world asset to this integer in a way that is completely secure because of the reality in the physical world. And by grounding or pegging it to a real world tokenization of space and time, you get the closed loop, you get complete closure on the authenticity. And we'll talk on the show over the months, hopefully future editions of this Stanford Blockheads podcast, exactly how that works. We're getting ahead of ourselves. So let's get back to the non-fungible tokens and the rug pull problem. So early on, as you remember, we bifurcated. We went to empty NFTs for ticketing, event ticketing, and that's solved now. We built that. And then we focused back chronologically. They came first, but we built them out first, although a big emphasis had then been laterally on the empty NFT ticketing. Going back to the non-empty NFT, traditional non-fungible tokens, we tied in directly and completely with the interplanetary file system.
I love the IPFS.
The IPFS you will see on our app and our website and everything we do is the guaranteed way of avoiding the rug pull in a traditional digital artwork, music, content, NFT. And what's brilliant about the interplanetary file system is decentralized, just like Ethereum itself. So no individual organization controls it. It's completely floating amongst the individual nodes, and anyone can set up a node, and in time we'll explain to people why they should and how they can. Same with their Ethereum nodes. But the beauty about the IPFS is not just that it's decentralized, but rather than it being a URL, which is an address to some content that sits in a file server somewhere, a JPEG, an image, a video, the interplanetary file system encodes the content itself to give a unique address, which is called the CID address on the interplanetary file system. But it is unique and completely bound to the content itself. So if the content changes and you create an IPFS presence, you will get a different identifier.
Wow. So let me just make sure I understand that completely, Yusuf. So basically you're saying that if I load, say, traditionally, like I've got chickenpie.jpg, if I load that file, I just took a picture and I name it that, and I load it up onto, like, say, my my cloud drive, Dropbox or Google Drive or whatever, and then I share that link, I share that URL out there to anybody, right? Then that means that anybody who clicks on that can see that file that I uploaded into the cloud. Now, but say, for example, I take another picture of chicken pie, but I call it the same name, and then I load it up in place. So I take the original one down that was called chickenpie.jpg, and I put the new one up, chickenpie.jpg, in the same place. And if somebody goes to that URL to see that thing, they're going to see a different picture. So it's the same URL, for example. Say it's on my website. Say I've got, sacredsteve.com/chickenpie.jpg, right? If I put that new file up there, then they're going to see something else, but they're going to go, well, wait a second, that's the same URL. I clicked on that URL, but it's showing me something different.
That's the rug pull. And the worst case of the rug pull is it shows you nothing. That the chicken pie JPEG is not a blank screen. There's nothing there.
They deleted it from the cloud.
IPFS.
So what you're saying, let me just finish. What you're saying is that what IPFS does is it takes the actual content, the actual ones and zeros, the pixels themselves, and it basically I think what is it called? It creates a hash of that,
Yeah.
right? It creates a hash of that data, and as a result, creates a unique long string of alphanumeric characters, and that is forever the unique single identifier of that particular file, the pixels, the data, the name of the file, the whole thing. So then, if I try and do that again, it's impossible because it would. If I put up a different picture of chicken pie, then it's going to have a different unique identifier by definition.
It cannot be the same. Now, you could argue that mathematically, you've got a compression. You're taking a video. Oh, there's David Byrne talking heads once in a lifetime. You can take that whole video, compress it down to 44, 64 character hash. Well, that's a lot. That's a compression. So surely you can have another piece of content that compresses down and give the same identifier, because that's mathematically a valid statement to make. You will get the same identifier from different content. But because of the length of it, because of the length of the hash, it's with the classic, every computer in the universe working for the age of the universe would not be able to get those two to match. It's a little bit like mining in the blockchain, the old days of mining. It's a little bit like the blockchain private key encryption. The chances of hitting it on the head by guessing are impossible in the known universe. There wouldn't be enough time to guess. Same with the CIDs on the chicken pie's just seen an armadillo on TV. Off we go. So the point I would make is that the absolutely brilliant thing about the IPFS is it absolutely saves the NFT, the digital NFT, because it allows that CID, that IPFS identifier, to be welded in to the blockchain itself. So now you have your NFT on the blockchain. Not only does it have an identifier, an integer counting number, but it also has the unique CID for the IPFS content. And that little package is valuable because that little package is complete and consistent and immutable, including the content itself. So that's what saves, in my view, that's what saves traditional digital NFTs. And that's why on Teckel, I'll speak about you in the third person, we only ever create or mint NFTs with IPFS encoded content. We don't allow on our platform any other type of content. And that's it. So by doing that, the digital content is immutably tied to the token on the blockchain, and that is what you own. Now, we still have the human in the loop issue of, but I can copy that content and I can forge it and pirate it and away I go. And my answer to that is, well, so what? That's normal fraud and crime. People do that all the time with artwork, with physical artwork. We can't solve that, not with the blockchain. But we can address the issue of provenance and uniqueness.
Yeah.
And that's why it's a fantastic medium for collectibles, because that is all about provenance and uniqueness.
Yep.
This will be the only version ever to exist. There will be copies, there will be fakers, doesn't matter. And there may or may not be an ascribed value to this. I think it's valuable. I might buy it.
You'll have to fight for me over here.
Okay, I'll fight for you. But our little AI camera keeps changing its mind on who it likes the most. I like the way Chicken Pie likes the Clash. He's watching Rock the Casbah on YouTube. It's because of that armadillo. He saw that little armadillo.
He's waiting for it to come
back. And he's very patient. He's patient. He's like the blockchain. He's a very patient beast. So there it is. There's the armadillo, but he missed it. He's missed it. So
that's great. So basically, by combining IPFS technology with blockchain technology, it creates something that because of the blockchain, you can have a chain of provenance, which is amazing. Because of IPFS, you can have a uniqueness to that provenance, and then so long as what they call on IPFS, so long as that file is pinned, which maybe you can explain a little bit what that means, Yusuf. Nobody can take it down. It's what they call decentralized, especially if it's pinned on multiple nodes. And that's the beauty of it, is you can ensure that it is pinned on multiple nodes, and there's nothing that anybody could do to take that down.
That's right. You can't, unless you stop the internet, and unless you stop the backbone of the internet, you chopped all the fiber and you stopped all the routers and the switches on the internet. It's there forever. So pinning, let's just talk about that a little bit. So this content we talked about that is encoded into these CIDs, and you upload it, and on teckel, as people will see tonight or tomorrow, they can upload anything they like to the IPFS through our gateways. It gets stored on in simple terms, it gets stored on the node or the server that you upload it to. So in the case of teckel, that content would initially be stored on servers that teckel is responsible for. But the beauty of the IPFS network and system is, as soon as it's up there, it gets broadcast, its existence gets broadcast out to the nearest neighbors, the nearest nodes, and they can all grab it.
Mm-hmm.
And so if someone in Tokyo wants that picture of chicken pie, they can go onto their IPFS gateway browser or use the teckel app and download it, and it will get taken from a node that they address. It doesn't need to be ours. Now, where is this information being held? We all know that all bytes matter. It's got to get stored somewhere, and this is the storage issue, which is actually subtly separate from the network and addressability issue. So that's where pinning comes in. So in our case with teckel, when you upload to our nodes, you have the ability to pin on our nodes, which means you can decide, I want this content to stay forevermore on that physical node, that physical server.
Mm-hmm.
And then once it's pinned, it cannot be removed. It will not be purged by the IPFS system. And like you say, you can go to another server somewhere else or your own node and pin it there too. Mm-hmm. So now you get 2 copies of your content pinned in individual locations. Mm-hmm. You can imagine 10 copies of it pinned across the world. And as long as that pinning doesn't get unpinned,
as long as one pin exists somewhere,
then that content's secure.
It's secure.
As long as the network's secure. Now, the question is, how do you pay for that? Because storage doesn't come for free. So pinning services typically charge per gigabyte hour or whatever, like we do on teckel. But it's very modest compared to what you gain. And what you gain is a decentralized, outside of the control of any organization or any individual organization or individual, certainty that your content is persisted out there forever.
Mm-hmm. So let me just summarize a little bit as I wrap my mind around this, Yusuf, is that basically that IPFS CID, which is forever connected to my file, that long string of alphanumeric characters is what is basically sort of pinned in these different nodes out there. And then the pin itself is basically almost like renting a little physical space on those nodes to sort of place that CID. But basically, that CID is recognized throughout every node, every IPFS node in the world. So it doesn't matter. So long as that CID is identified, you can retrieve that data so long as so long as that CID has been pinned on some physical node someplace. Whereas in comparison, if you're talking about something, say on Google Cloud or Azure or AWS or something like this, if they take that down, that is, you can't do anything about that. Whereas with this situation, if you've got that CID, you can always grab it from another node somewhere else in the decentralized file system. Is that
that's exactly it.
Okay.
It's not under any central control. And these cloud storage solutions have been around for a while. They're very powerful, very useful. We all use them. I use them.
Mm-hmm.
I still use them. But they're not decentralized, and you are at the mercy of those organizations. They can change their terms. They can go out of business. They can change their pricing.
They can take it off their platform if they don't like it.
They can censor it. That's
They
right.
can censor it.
Rules of censorship, not necessarily a bad thing, but it might come up against your views on acceptability. So, for all those reasons, I think it's very useful to have a decentralized storage universe. But by far, for me, the most powerful argument for the IPFS isn't necessarily the fact that it's decentralized per se. It's that you get a content-defined addressing. So you have absolute uniqueness in the address paired with the content. And that makes the NFT supremely useful.
Mm-hmm.
It brings back utility to the non-empty NFT.
Mm-hmm. Mm-hmm.
And we will hopefully convince people through our app, where we have, half of our app is dedicated to these non-empty NFTs, where people can. We have an example. You remember from Stanford, Steve, my pop punk band, The Havering.
Yep.
We made an album called Silent Maniacs Volume 1 at Bart's House of Faith Studio in Palo Alto, here in California. And we made that record, 17 songs, I think it was. And we've now, as an example of the NFT capability with the IPFS backstop, we've put those 17 songs up as a collection on the. We put those 17 songs up as a collection on the blockchain on Teckel. We just need to stop it from tracking. There we go. We put it on. We put that up there. Those 17 songs, and you can trade them. And the beauty of that is that each song from the Havering is now permanently, immutably addressable on the Ethereum blockchain via this Teckel NFT with IPFS content encoding for every unique song. So that's an example where artists, not calling myself an artist, but for the sake of argument, where artists can market their wares, their digital music, their digital videos, their digital artwork on the Ethereum blockchain with total confidence and security and resilience. I think it's a good use case, but personally, I would say that the connection with those digital assets, but for me personally, what I find most fascinating, intriguing about this whole venture that we've embarked upon is the connection with the real world assets. Those securing those on the blockchain is a remarkable innovation, I think, in commerce.
Yeah, I want to interrupt you for a second.
Okay, Steve, no problem.
I just want to show people out there what you were just talking about.
Great,
the Havering Silent Maniacs Volume 1. So here it is. This is. Let me just show everybody here on the Teckel app. Here it is right here. So these are the old picture of the old cassette tapes right there on the Teckel app, and these are actually NFTs live on the Ethereum mainnet, and they're audio files. So, they're music files. So if I go ahead and examine these to make sure that, say, I want to actually purchase one of these as an NFT, right? I can go ahead and
Chicken Pie's fascinated with this demo. He's actually checking that you're doing it right, Steve. But he's yeah, you're okay. You're okay.
here. Hold on. Wait a second. Let me click on this for a second. And, I guess I have to go here.
When you want to go to the top.
Yeah, go over to the tokens and let me just get this going here. Here we go. Silent Maniacs. So if I click,
That's it.
there you go.
There we go. The first ever rendition of the Havering from IPFS and Ethereum blockchain to the teckel app. So that's available for anyone interested in listening or trading those NFTs. But that's great, Steve. Thanks. That's an example.
Yeah.
It's an example of how we. That's an example of how we can utilize teckel and the NFT infrastructure coupled with IPFS.
Yeah.
In a meaningful, sensible way. But as I was saying, it's the empty NFT connection with the real world assets that I find particularly exciting. And there's another one. So there we go. So that's one we've put up. We're launching now, but our sort of big launch party is going to be in Paris in the middle of the month at a large NFT RWA conference, where we will go and meet all the other folks who are interested in this type of thing, and hopefully we'll learn a lot about what others are doing with real world assets. But
yeah, if you're listening out there and you're gonna be there, look us up. We'll be walking around.
Yeah, and so what I'd say about that real world asset example that's exciting is you have this idea of making a transaction between two parties who don't necessarily know each other or trust each other without the middle agent in the real world on the blockchain. And so the example that's up there is I have my two sons have now left home, as your daughter has, Steve, as you know, and they're off doing their own thing. So I've got spare capacity in my living accommodation. And again, in the interest of efficiency, I've come to the conclusion the best thing to do is to rent the rooms out on a sort of B&B basis. And then I thought, well, do I really want to have to deal with agents and all the rest of it? And I thought, no, I don't. What I'll do is I'll put that property rental capability or possibility on as a ticket on teckel, where each ticket that you buy is one calendar night of reservation. And we'll have another edition where we talk in detail about how it works, how the ticket redemption works, how everything works. But the beauty of that is it's a real world asset defined on the Ethereum blockchain and tradable in a secure manner. So that to me is very exciting. And it's like you said earlier, there are so many examples of use cases where that kind of pattern can be followed, where you take a real world asset, a physical thing, you tokenize it in space and time, and you trade it on the Ethereum blockchain. So I'm thinking now we might want to move location. What do you think about that,
Sounds
Steve?
good.
I think we've been here now for a good hour or so.
Well, before we move locations, I just want to check something real quick here.
Chicken Pie is excited about it.
Yeah, I just wanted just wanted to share with everybody out there about we've in setting this all up and setting up the teckel app. We've created our own. Well, we've got certain agreements and certain things. We've got our own infrastructure. We've got various agreements and so on in place. But we have some spare capacity, and so we are we want to share that spare capacity with the Web3 community in basically in the most economical way possible for everybody involved. So when we launch, we will actually make some of the spare capacity available for other Web3 developers out there to utilize so that they can continue to develop their dApps in the most economical fashion possible. Do you want to just talk a little bit or mention what we are actually going to offer in that realm?
Yeah, well, I think it comes basically in two flavors, Steve. And again, it was necessity being the mother of invention. We had to build this capacity for our own purposes.
Mm-hmm.
The existing capabilities out there and offerings were just frankly too expensive,
mm-hmm.
and they weren't performant enough for
mm-hmm.
our needs. When people see teckel, they realize there's an awful lot going on.
There's a lot going on.
There's a lot going on behind the app, behind the scenes, on the infrastructure side. So we had to basically create that. We have, like you say, partnerships with the various cloud operators and ISPs to realize the connectivity with the user base
mm-hmm.
globally. But the core deep infrastructure we had to realize in an efficient way. So the two pieces I would say that make the most sense to talk about now, we can talk about more later. IPFS.
Mm-hmm.
So we rely on IPFS for our NFTs, our tokenization of digital content.
And we just brought on another 16 or 20 terabyte?
Yeah,
just another whole chunk we brought online.
Last night we put another server up to 20 terabytes just in preparation for this launch. So people have access to the IPFS network through teckel, I believe, in the most cost-effective manner. I don't think there's a more cost-effective on-ramp to the IPFS.
I mean, we've done a thorough search, but we haven't searched every nook and cranny on the internet.
but that's my feeling. And then the other one is more so that's for anyone. We used to call it create while you wait. If you're an artist or a musician or a poet and you've got your artwork on your phone, you can create an NFT through the app in 1 or 2 clicks. And then you have your NFT, you can start trading it in the marketplace.
And it's on IPFS.
It's on IPFS, it's on the Ethereum blockchain. So from that point of view, we're offering the Web3 infrastructure of IPFS on ramping and downloading, so both directions on IPFS. But the other one is more for developers like ourselves, more for people who are building similar things,
mm-hmm.
to utilize the Ethereum blockchain for all kinds of innovative purposes. In order to do that, the blockchain exists in all these decentralized servers all around the world, but you need to talk to it. You need to communicate with the blockchain, no matter what you're doing. And there's a protocol, the RPC protocol of Ethereum, and many other software platforms use that same. It's an old protocol, but it's very worthy,
mm-hmm.
reliable, and efficient protocol. The RPC communication with the blockchain is effected through yet another set of nodes or servers, if you want to call them that, on the Ethereum blockchain. And the connectivity in is a service that people offer so that developers like us or anyone can talk to the blockchain, push their contracts, interact with their contracts, buy and sell their NFTs, whatever they want to do on the blockchain. You need to go through these RPC nodes, as they're called. So it's like you said 10 minutes ago, Steve, we've got such overcapacity because we built it to be future-proof, to use the cliche, and we're going to offer that out, as we've discussed, to the developer community at, I believe, again, rates that are highly competitive. I've not seen anything that comes close in terms of the cost effectiveness of our putative RPC connectivity. That's going to be not released in Paris. As we've discussed, we're going to hold back on that until probably later in the month, maybe early March. We just want to make sure that we have the scalability and capacity online for hopefully a rapid growth in usage of that. But that's right. So those are the two pieces. There's the IPFS on and off ramping, and there's the Ethereum blockchain RPC networkability that we're going to offer as what we call Web3 services.
And then what about, I just want to touch also on the smart contracts themselves. I mean, we've got 3 different types of smart contracts on the teckel platform. We've got what we call TIQYUs, TIQYU. That's the symbol on the Ethereum blockchain, TIQYU. How we call it TIQYU. And that is the empty NFT.
The ticketing.
The ticketing. We've got MIQYUs, same spelling, only with an M instead of a T, so it's MIQYU. And then we've got TIQYUs, again, PIQYU. And the MIQYUs and TIQYUs are NFTs with content. So they've got that metadata CID, obviously embedded immutably into the NFT on the blockchain. Those, of course, I just want to mention that before we get into the bartering of the MIQYUs and the TIQYUs, which is a whole subject in and of itself, I want to touch on the fee structure of our contracts and the fact that we're trying to make it as economical as possible. So it's almost like I look at this like you can go to different websites out there, for example, and you can say you need a real estate transaction document. You can pay a few dollars to a legal website and download sort of a boilerplate contract and then print it out. Fill in all the fields, sign it, get it notarized, off you go, right? So in a sense, the Ethereum blockchain is kind of doing that only electronically on this public decentralized ledger. And so we're, in a sense, smart contract authors, right? And so what we're doing is we're saying, hey, anybody in the world, you can utilize the smart contracts that we've designed, tested, deployed out onto the Ethereum mainnet, and you can do it for a very economical fee, and it's a flat fee. So even if the contract is executing a transaction worth millions of dollars, we're only charging, what is it, about $1 right now to do that?
Yeah, at today's rate's about $1. And I think that's key. We're back to the old model of utility pricing. It's like when you buy a property, a house. I've always felt it's unfair that a real estate agent can charge for conveyancing a percentage of the house value. And they're doing the same amount of work, whether it's a small house or a big house, roughly speaking. So why is it not a flat fee?
And it makes it unfair, because then those real estate agents are really providing all the work and the service more so for the big transactions than they are for the small transactions. So it's kind of, for the person who's got a humble house that they're selling for a fraction of the cost of a mansion, they're not really getting the same time and attention.
That's right.
Understandably, from that real estate agent, because the way the thing's designed.
So a lot of the NFT marketplaces, when you buy or sell an NFT, that marketplace, the owner of that marketplace, the operator of that marketplace will take a percentage. It will take a percentage of the underlying asset value as a transaction fee, a commission, basically.
It's a commission, yeah.
So we don't do that. We definitively don't do that, because we think your revenue, your business. That's our tagline. We don't want to do that. It's philosophically doesn't sit well with us. So we charge flat fees for anything related to our contracts, no percentages ever, anywhere. And the other thing I wanted to say about the MIQYUs and the PIQYUs, why do we have two flavors, MyQ and TIQYU? The main reason is a couple of years ago, the main marketplaces out there abandoned creator royalties because they went out of favor. And so when we got started, we thought, well, we're all about the individuals, the creators, so we wanted to retain those creator royalties. So we built into our contracts in the TIQYU this concept where you can trade it on the open market, just like any other NFT. But after a certain amount of time, which is set by the NFT owner, it must come back to the teckel platform to be traded. And the reason why it must come back to the teckel platform is once it's being traded on the teckel platform, we can absolutely guarantee the creative commissions are paid. So it's a way of somehow combating this move away from royalties and creative commissions. Now, I know that they've made addendums to the 721 contracts, the Part C, to try to address that, but that's a fairly recent innovation. I think our TIQYU ID is stronger in that we're forcing the token to be brought back home. It reminds me a little bit of these robotic vacuum cleaners. Every so often, they have to come back for a recharge. You know what I mean?
Yeah.
So every so often, the TIQYU has to come back for a reality check.
Yeah.
Don't forget who created you.
Yeah.
So that's the main difference between the MyQs and the TIQYUs. So I think that's a pretty good introduction. I think what we might want to do is change location for the next part of our pre-launch launch party. But before doing so, I just want to play a little bit of Ian Jury and the Blockheads on the Way Out. Reasons to be Cheerful, Part 3.
Blockhead number 1. Thanks for blasting Ian Dury.
Reasons to be cheerful, Part 3. Summer Buddy Holly, the working folly, good golly Miss Molly, and boats. Hammersmith Pally, the Bolshoi Bally, jump back in the alley, add nanny goats. 18-wheelers camels, Dominica camels, all other mammals plus equal votes. Seeing Piccadilly, Fanny Smith and Willie, being rather silly, and porridge oats. I better grin and bear it, I better come and share it. You're welcome, we can spare it. Yellow socks, too short to be haughty, too nutty to be naughty. Going on 40, no electric shocks. The juice of the carrot, the smile of the parrot, a little drop of claret, anything that rocks. Elvis and Scotty, days when I was spotty, sitting on the potty, curing smallpox. Reasons to be cheerful, Part 3. Reasons to be cheerful, Part 3.
So we're going to pause for a bit. Stanford Blockheads are signing out for a few minutes while we change location, and we'll be back with you soon.